Hi and welcome to Maths class. Today we're looking at factorising, and so we're going to start with a little bit of a review to remember what factorising means, to make sure that we understand what we're doing, and then we're going to start looking at some factorising patterns. So let's just start by thinking, well, what do we do when we factorise? Take your mind back to when we first met factorising with numbers. For example, I could rewrite 12 as 3 times 4. Oh, I'm in red. Let's change that. Or I could rewrite 12 as 6 times 2. I can even write it as 12 times 1. Or I can take it further and say it's 3 times 2 squared. That gives all my prime factors. So this is completely factorised now. But all of these is factorised. In other words, I'm rewriting the number 12 as two other numbers multiplied together. And it's this multiplying together that makes it a factor. Let's look at 50. 50 is 25 times 2, or it's 5 times 10, or I can write it as 5 squared times 2. This is completely factorised. So in this version, I've actually got 3 factors, 5 times 5 times 2. So I can have 3 factors, okay? So for example, write down the possible dimensions of a rectangle with area 30. So here's my rectangle. Oh no, hang on. Let's try that again with some straight lines. Here's my rectangle. There, and there. That's better. What might the side lengths be if it's a rectangle and the area is 30? It could be 10 and 3. So 10 by 3 is an option. It could be 15 by 2. It could be a 30 by 1. What other options are there? 5 by 6. Am I missing anything? I think I've got them all. Okay, so this is an example of when we might use factorising. If I know that the area is 30 and I don't know the side lengths, that's what I can do. So what's that got to do with algebra then? Well, when I factorise something in algebra, I change it from what we call expanded form into factorised form, which is actually two things multiplied together. There's a little invisible times here. When I write 3 open bracket x plus 2 close bracket, I really mean 3 times all of x plus 2. And that's why when I expand it, I go 3 times the x and 3 times the 2, because I have to multiply by all of it. So if I look at these brackets, x plus 2 times x plus 1, there's a little invisible times here. There's a little times here. So when I'm expanding, I multiply this out so that I get something, that looks like this on the right. When I'm factorising, I'm going back the other way. So this is factorising. When I'm taking it from expanded form into factorised form, and this is expanding. When I take it from factorised form into expanded form. So we've always got to read the instructions on a question. If it says simplify, I don't want to factorise, okay? If it says factorise, then that's what I do. And if it says expand, then that's what I do. So what we're going to start with is a little bit of revision. Here's an example. This is, if you remember, x minus 1 times x plus 1. This is a difference of 2 squares pattern. This is how it looks in factorised form, and this is how it looks in expanded form. Now, if you're in my class, you can go to Compass and find the factorisation and expansion worksheet, and you can open it up and you can write on it or copy it if you want to. Pause it now to go and find it, because I want you to have it in front of you. If you don't, then you'll simply have to copy this down and fill in the gaps. But that's exactly what I want to do. I want you to do is fill in the gaps. So for example here, this one's a perfect squares expansion. Now, please follow my instructions when you're doing this. Don't just go your own way. What I want you to do first is this. I want you to decide what it's going to be. Is this a difference of 2 squares, or is it a perfect squares expansion? Well, this one is a perfect squares expansion. You can just write PS or dots, okay? Then write it in expanded form, x squared plus 10x plus 25. Okay, so just do the next 4, pause and do the next 4, and then come back and look at the answers. hopefully you got the answers I got. Now, what I want you to do now is to have a look at the next examples. And let's just scroll up a little bit, because now the gap is in the factorised side. So what I want you to do is think for yourself. First of all, what kind of expansion pattern is this one? Looks to me like it's a dots, because I've got a difference of 2 squares. This is x squared and this is 9 squared. Sometimes with these it helps me to write this as x squared minus 3 squared. Okay, what's in brackets here? You fill it in. Okay, see if you can do that for all of these, because what we're going to be doing is learning the patterns, but I want you to start thinking about it yourself first. Hit pause, do the ones you can, and then I'm going to talk it through with you. Okay, so hopefully you've done it and now you've hit play again. So here we're going to have the pattern for difference of 2 squares is x plus 3 and x minus 3. Now if you had x minus 3 times x plus 3, that's the same thing, so it's correct. This one though, see, remember that the dots has only 2 terms in it. The terms are both squared and there's a subtraction in the middle. This is a perfect squares pattern and this is positive. That's a key clue. I've got something squared. This is x squared. And on the end I've got 3 squared. And this is double of x times 3. So what I've got here is x plus 3 all squared. Okay. The next one is also 3 terms, so it's not a dots, it must be a perfect squares expansion. Let's check the pattern. Here I've got x squared. Here I've got 6 squared, so in the middle I should have x times 6 doubled, and I do. So that's x plus 6 squared. Now I've got 2 terms and a subtraction in the middle. This is definitely a dots, difference of 2 squares. And it's x squared minus 9 squared. So my 2 brackets are x minus 9 times x plus 9. And if you had it the other way around, x plus 9 times x minus 9, perfectly correct, it's the same. In the same way as 5 times 4 gives me the same answer as 4 times 5. I can swap these brackets around. 3 terms, it's a perfect square. Oh, what is going on with this thing? Perfect square. But be careful here, I've got a subtraction. So I've got x squared and I've got 4 squared. And here I've got x times 4 doubled, which gives me 8x, and it's subtracted. So this is x here and 4 here, and the difference is I've got a subtraction in the middle. And this next one looks like the same pattern. This is x squared. This is 5 squared, and this is minus double of x times 5. So I've got x minus 5 all squared. All right, I'm going to show you the worksheet and I want you to fill out all the gaps yourself. The last 2 are a choose your own adventure. So make up your own. I don't care whether you start on this side or this side, but make sure that those 2 match, okay? So what we're starting with here is we're expanding. Oh no, you need to pause. Don't be watching until you've done it. Pause and do it and then come back. All right, so this is dots because I've got 1 negative and 1 positive bracket. So this one gives me x squared minus 4. Oh, look what I've done. I've given you a gift. That's exactly the same. Okay, now this one is again a dots because 1 bracket is added and 1 bracket is subtracted. So that's dots. And so it's going to be x squared minus 6 squared. Oops, which is x squared minus 36. I forgot to write the answer. All right, my last one is not a dots. It's x minus 5 squared. That is a perfect square. And I've got the negative in the middle, so my middle term's going to be negative. So I've got x squared, the first term squared, minus 5 times x is 5x, doubled is 10x. And then I add 5 squared, which is 25. Okay, this one follows the same pattern. It's another perfect square. So I've got x squared here, and I've got 7 squared here, and in the middle I've got x times 7, which is 7x, doubled, that's 14x. So that's x, and that's a subtraction, so I want minus 7 squared. Okay, one more perfect square, and I've got x squared plus 2x plus 1, so this is x squared, and this is 1 squared, and in the middle I've got 1 times x, which is x, doubled, which is 2x. So this is x, come on, x plus 1 all squared. Okay, so hopefully you've checked your answers and you've gone okay. So when we are factorising, we use these expansion patterns. If I see 2 terms squared and a subtraction in the middle, I can write it in brackets. This is the same rule we learnt before, but I've written them with the other thing on the left side and the right side. I've just swapped around the left and right sides. Here I see a pattern of something squared on this end and something squared on this end, and I've got to check that the middle term is double those things multiplied together. And the same thing here, but with a negative. So now it's practice time. So we're factorising these expressions. If you want to have a go yourself, have a go. Otherwise, if you want to watch me, that's fine. So what I'm looking for is the fact that here I've got x squared and I'm subtracting 5 squared. So this is clearly a dots. And then I can put it in brackets, x minus 5 and x plus 5. In this one, I've also got a dots. There's my subtraction, and I've got to remember that this is 4p squared minus 3q squared. So this is a complicating factor here. I haven't seen these yet, where I've got to think about not just the p squared, but this 16 is also something squared, and this 9 is something squared. So this is 4p minus 3q multiplied by 4p plus 3q. Okay, here, again, I've got x plus 2 squared minus 3 squared. Don't be tempted to expand this out, right? I'm factorising. That's why it's really important to read the question. It doesn't say expand and simplify. It says factorise. So I'm looking for the dots pattern. This is a dots pattern. The first term is x plus 2, and that's squared. And the second term is 3, and that's squared. So what I get is x plus 2 minus 3 multiplied by x plus 2 plus 3. It's a tricky one. Now I simplify. This gives me x plus 2 minus 3 is minus 1, and x plus 2 plus 3 is x plus 5. Now, if you've got a tricky question like this and you're in a little bit of doubt, what you can do is you can say, let's let x equal 2 and see if we get the same number. So I'm just going to change colour to do those scribbles. If I make x 2 here, I'm going to get 4 squared minus 9, which is 16 minus 9, which is 7. Down here, I'm going to get 2 minus 1, that's 1, multiplied by 2 plus 5, which is 7, and that gives me 7. So I got the same answer for the original and my version, which means that they're likely to be equivalent expressions. Now, you know, if I wanted to be 100% sure, I could choose another number and check again, but that's good enough for me. Okay, last one on this page. This one's a little bit trickier again because look, that's not a perfect square and neither is that. But what I can see, and this is something you should always check for first, is a common factor. 5 goes into this term and 5 goes into this term. So first, I write it as 5 times x squared minus 9. Then I look at what's in the bracket. This is x squared minus 3 squared. So that's x minus 3 times x plus 3. Now this is fully factorised and this one has 3 factors. The first factor is 5, the second factor is x minus 3, and the third factor is x plus 3. Okay, we're going to have a look now at some perfect square expansions. So remember that if I've got a plus b all squared, that expands to a squared plus double a times b squared, sorry, a times b, not squared, plus b squared. So I just think about this is x squared and this is 5 squared, and I check that this is x times 5 doubled, and it is. So that means I've got x plus 5 squared. So if I'm asked to factorize this, then that's what I've done. This is now in factorized form. Let's look at this example. I've got p here, squared, and I've got 6 squared here, and in the middle, I've got 6 times p doubled, which is 12, but I've also got this negative here. So that means I'm going to have p minus 6 all squared. Well, now this one looks really complicated, but it's not, because look, this 81 is a perfect square and this 4 is a perfect square. So I end up here with, this is 9x squared plus 36xy plus 2y squared. Don't need to write that line out, I just do it to help me. So I'm just going to double check. 9 times 2 is 18, doubled is 36, and then there's the times the x and times the y. So this is 9x plus 2y all squared. And the last one, oh, I think I made a mistake on this one. Yeah, let's ignore this one because I made a mistake when I was writing the question. Okay, so that's the end of our video on factorizing using expansion patterns.